Welcome to the second part of Lesson 3.3, Energy Flow in Ecosystems. In this lesson, we'll continue to trace the flow of energy through living systems and explain how ecological pyramids show the flow of energy through trophic levels. Let's take a look at another food web. What is the primary producer in this Antarctic food web? The answer is the algae. Now take a look at the krill. All of the animals in this food web depend directly or indirectly on these organisms. Krill are an example of a diverse group of small swimming animals called zooplankton that feeds on marine algae. What do ecologists mean when they say that killer whales indirectly depend on krill for survival? Well, krill are the only herbivores in this food web. Without krill, the animals the killer whales eat would not survive. In recent years, krill populations have dropped substantially. Over that same period, a large amount of sea ice around Antarctica has melted. With less sea ice remaining, there are fewer of the algae that grow beneath the ice. What do you predict what will happen if the krill population decreases? Well, a drop in the krill population may cause drops in the populations of all the other members of the food web. How might an increase in the herring population affect the emperor penguin population? Emperor penguins eat herring. An increase in the emperor penguin's food source would likely lead to an increase in the emperor penguin population. Suppose the killer whale population is significantly reduced by disease. How might this affect the leopard seal population? Well, a decrease in the killer whale population might lead to an increase in the leopard seal population because killer whales are the leopard seal's only predator. Each step in a food chain or food web is called a trophic level. Primary producers make up the first trophic level. Various consumers occupy other levels. One way to illustrate the trophic levels in an ecosystem is with a model called an ecological pyramid. Ecological pyramids are models that show the relative amount of energy or matter contained within each trophic level in a given food chain or food web. There are three different types of ecological pyramids: pyramids of energy, pyramids of biomass, and pyramids of numbers. Only a small portion of the energy that enters any trophic level is available to other organisms at the next level. This is because organisms expend much of the energy they acquire on life processes such as respiration, movement, growth, and reproduction. Most of the remaining energy is released into the environment as heat. Pyramids of energy show the relative amount of energy available at each trophic level of a food chain or food web. On average, about 10% of the energy available within one trophic level is transferred to the next trophic level. To outline this decrease in energy, start with 100% of the energy in the primary producers. How much energy is available for first level consumers? Only 10%. How much energy is available for the second level consumer? Only about 1%. And how much energy is available for the third level consumer? 0.1%, or 1/1000th. If this food chain included fourth level consumers, what percentage of the original energy would be available to those organisms? The answer is 0.01%. Why is a pyramid a good way to represent flow through trophic levels? Well, the pyramid shape represents a decrease in energy at each level. If there are 1,000 units of energy available at the producer level of the energy pyramid, approximately how many units of energy are available at the third level consumer? Would only be 1 unit left or available. What is the original source of the energy that flows through most ecosystems? Why must there be a continuous supply of energy in the ecosystem? Solar energy is the original source of energy in most ecosystems, there must be a continuous supply of energy because energy, unlike matter, flows one way through ecosystems. Energy that is converted to heat is lost to the environment, so more energy must enter the ecosystem to replace it. Why are there fewer organisms in the top levels of an energy pyramid than in the bottom levels? There are usually fewer organisms in the top level of the pyramid because there is much less energy available. Include an example of a pyramid of energy in your notes. The total amount of living tissue within a given trophic level is called its biomass. The amount of biomass a given trophic level can support is determined in part by the amount of energy available. A pyramid of biomass is a model that illustrates the relative amount of living organic matter available at each trophic level in an ecosystem. Ecologists interested in the number of organisms at each trophic level use a pyramid of numbers. A pyramid of numbers is a model that shows the relative number of individual organisms at each trophic level in an ecosystem. In most ecosystems, the pyramid of numbers is similar in shape to the pyramid of biomass. The numbers of individuals on each level decrease from the level below it. In some cases, however, consumers are much smaller in size and mass than the organisms they feed upon. Thousands of insects may graze on a single tree, for example, and countless mosquitoes can feed on a few deer. In such cases, the pyramid of numbers may be turned upside down, but the pyramid of biomass usually has the normal orientation. So, which pyramid shows the amount of organic matter at each trophic level? That would be a pyramid of biomass.